Good afternoon, everyone. We are going to study the sample size determination, inclusion, and exclusion criteria, which is the most important part of your study. Before we decide upon the sample size, it is important for us to consider that the moment we decide our topic, the aims and objectives, there has to be a representative number according to which we can go about proving our study objective or rejecting the null hypothesis. You have to keep in mind that if you take a very large number of study subjects, the chances of showing the difference of even trivial things increases, whereas if you take a very meager number, then even an existent difference may not be visible. So, the samples which are too small can prove nothing, and the samples which are too large can prove anything. So, the most important question which comes is how many people should I study? Though it looks simple, but the answer is quite difficult. Mostly you come with the research studies telling that the following study has used 10 patients, the following study has used 8 patients. It is important for you to know that it's not the number of subjects which is important from the research study. It is the parameters which the research study has shown to be significant or not significant, and those parameters, when considered by you in your studies, how important are those to be considered in a scenario of your study setting, the numbers required according to their results. So, when you take sample appropriate to the requirement, it is likely that the result which you get is also appropriate. There is no chance that you have got the result accidentally. Now, the sample size depends upon the type of study, whether it is a descriptive study or whether it is a comparative study, whether you have got a before and after analysis called as paired design, or whether it is an independent sample wherein you have got two or more groups which are to be compared among themselves, then the type of variable. Now, this is decided when you are deciding that how in the methodology I'll be measuring my effect or my parameter of choice. If it is a categorical variable, you use a categorical type of test of association, and the sample size uses proportion or percentage in the calculation. Whereas if it is a continuous variable or a mathematical variable, then we use the mathematical test such as t test or z test or the non-parametric test, whichever are suiting the data according to the normality basis. So the sample size, when you calculate, there are mathematical parameters which come into play, of which one is the power of the study, that is how powerful is your calculated sample size in detecting the difference which actually exists. Then the level of significance. You usually decide on significance by default as a p-value of less than 0.05 as significant, which is uniformly considered throughout as a one single number to define significance. Then is effect size. For example, if you want to compare two drugs, it is the investigator who decides that what's the effect of the drug on hypertension. Say, for an example, what level of drop in the BP is considered as a drop. A person who may be testing the drug in a hypertensive patient who is in grade 1 or grade 2 hypertension, for him a drop of 5 mmHg may not be holding true, whereas a person who is considering in pre-hypertensive or grade 1 hypertension early part, there the drop of 5 mm may be significant for him. So effect size depends on the choice of the investigator what he wants to take. Coming on to the study designs for a single group study, if you have got a continuous variable, for example, the mean and standard deviation is given, then the number of study subjects are calculated using the mean and standard deviation from the study using this formula, wherein the sample size requirement should be more than or equal to 1.96, which is a constant Z value for a alpha of 95% confidence level, and the given two mathematical parameters are the mean and the standard deviations. This is an example which tells that if you have to estimate the diastolic blood pressure of a population within 2 mmHg. Now this is the deviate they have given, and the standard deviation which is known is 15 mmHg. So then the equation required will be how much is required, 1.96 multiplied by 15 mmHg divided by plus minus 2, which is given as the deviate, and that will give you the sample size approximately. The next higher integer is taken. So if the number is coming as 216.09, you need not round it off to the lower side, because this may affect the power of the study or the confidence level which you are going to attain. So you take 217 subjects. If it is a categorical variable setting, then in a cross-sectional study, you use this formula, very common formula, and is Z alpha square PQ by D square. In this, P is the proportion of the characteristic of interest. For example, you are testing the anxiety level. Anxiety level is say 30%. So those who are not having anxiety is 100 minus 30. If we talk about percentage, if we talk about proportion, then it is 1 minus 0.3. So this is, once you put these in the formula, descending upon the level of precision which is in the denominator, the delta, it will give you the value of the desired result of the number of samples required for the particular study. Now you have to consider that delta, at some times it is used as absolute precision, at times it is used as relative precision. Absolute precision is when you estimate p within a defined percentage points, and relative is when it is used by you in consideration to a reference study. It basically is the choice of the investigator whether he wants to use a relative precision or absolute precision. Many times people use absolute precision. At times, if the prevalence is quite low, then you use a relative precision which is with regard to the absolute precision. When you are estimating using the sample size a single proportion, the formula as told is z square pq by l square. The example for it, supposedly you think that there are 28% smokers in the population. It is required to estimate the percentage of smokers to have within 3% using 95% confidence interval. Then you put these values in the formula. You got 1.96 into 0.28. See, you mentioned the thing in the proportion, it becomes 0.28, and 1 minus 0.28 is 0.72, which is the multiplying factor in the numerator along with 0.28. In the denominator, it is 3%, so it is 0.03 in the denominator and square. So you got 861% before a non-response. So this is a summary slide which tells that simple random sampling is used to provide a confidence interval of a given width for a prevalence of a disease, indicating the range within which it is probable that true prevalence lies. A reasonable close estimate of the actual prevalence is required from the study. If in doubt, 50% can be used. This maximizes the sample size and hence the errors on the safe side. The maximum acceptable difference between the estimated prevalence based on the sample and the actual prevalence, that acceptable margin of error, is taken as 1/5 or 1/4 of the prevalence. This is the term which we call as relative precision. So the first point below the summary part is a reasonable close estimate of actual prevalence. That's why we ask for a study to be brought along with when you are writing the protocol for the thesis, so that the estimates from that study can be considered for the sample size calculation. Now, the sample size for comparison of two means of independent groups, that is, when you have two groups which are being compared and the outcome variable is preferably a continuous variable mentioned as mean and standard deviation. So, the formula for sample size is with n is more than equal to z alpha plus z beta whole square. Now z alpha is z value at 95% confidence level, and z beta is considering the power of the study, the beta error, type 2 error. So z beta is by default considered at 80%. 2 into s square divided by d square. Now this z alpha plus z beta, at times it is taken as a constant. So in short, you can write the same formula as 2 into k multiplied by s square by d square. Now this k is a calculated value at alpha of 5 and beta of 20, that is power is 1 minus beta, so 80% power. The k value is 7.8 for two-sided. whereas it is 6.2 for one-sided. At 1% confidence level, 99 1% type 1 error, that is alpha, power of 90%, the k value is 14.9 for two-sided and 15 for one-sided. So you see, once you improve the confidence level and the power of the study, k almost doubles from 7.8 to 14.9. So the sample. Now the s in the numerator was the pooled standard deviation. Now this is an example. Suppose a sample size is required for RCT to compare two different treatments for blood pressure reduction. The researcher wants to have the difference between the mean systolic pressure in the two groups of 10 mm or Hg. The non-stratified randomization is used so the two groups can be considered independent. So considering alpha of 5% and power of 80%, the standard deviation of systolic blood pressure given is 20 mmHg. You calculate the sample size, so it's 2. Again, putting in the formula, so S is the standard deviation divided by D square, which is the precision. You get 63 subjects. So a total sample size of 126 is required for the study, 63 in each group. Considering two independent proportions or percentages, wherein you have a categorical data, then the sample size calculation formula used is n is more than equal to k P1 1 minus P1 plus P2 1 minus P2 divided by delta square. It can also be written as K pi 1. So the difference between two proportions is given by delta. Important to notice that no estimate of standard deviation from the previous work is required, but the actual proportions must be specified. That's why we ask for thorough review of literature through which you can get good studies which are near to the reality. So this is an example which tells the same, that the proportion of exposure in controls is 25%, and it is decided that study must be large enough to have 80% chance of detecting exposure rate of 35 in the cases using the 5% two-sided level. Solution, that answer is k is 7.8. The other quantities, once we put in the values, 25% is 0.25, P2 is 35, exposure rate of 35% in the cases is 35, so it is 0.35. Delta is 0.25 minus 0.35 is minus 10, which is d square is 0.01. Substituting in the formula, you get the sample size as 323.7, rounded off to say 324 subjects or 330 subjects. When you have paired means, that is before and after study, the sample size gives n as the pairs, number of pairs required, k multiplied by sigma square by delta square. Putting in the values, you can get the desired sample size. Now, standard deviation of difference is difficult to determine at times. So, sometimes you are doing a study wherein two parameters have not been compared. So, you just do a pilot study and then estimate that value. This is another approach which gives a tabular form, that percentage difference from zero. This is used when there is a categorical difference obtained before and after in a study. So, this is used in a complex studies. Usually these are not done as a part of PG thesis. Even the RCTs are not done as a part of PG thesis. Most of the PG thesis is either done as a cross-sectional descriptive or an analytical follow-up study wherein one or more groups may be there. So to test whether there is a significant difference between the rate of disease in the two groups in the trial or an analytical survey, the requirements are important. A reasonably close estimate of the actual rate in one group, the magnitude of difference, that is in the form of odds ratio or a risk ratio, can be to be detected. The relative size of the two samples, whether you want to take equal numbers or 1 is to 2 or 2 is to 1 or 3 is to 1. The required significance level, the required power of the test, 90 or 80%. By default, it is taken at 80%. Now, this chart gives the summary sample size. If you have to compare mean in a single size in a group, then mean formula is zs by d square. For using proportions, z square pq by l square. For two independent groups, if there are proportions, the formulas are z alpha plus z beta square 2 times s square by d square, where s is the pooled standard deviation. For the proportions, you have k, that is again the constant z alpha plus z beta square, multiplied by p1 q1 plus p2 q2 by d square. And for pair detection of difference, they have n k s square by d square, where n is the number of pairs. There are softwares which are available for sample size calculation. Few of them are having open access, such as AppyInfo, OpenAppy, AppyData, PS Calculator, DOSBox, etc. At times, you can use nomograms which are there in many of the books for sample size calculation. There are other type of studies also wherein correlation is used. So you have different formula. There are complex statistics wherein more than two groups are there. In that, the formulas are very complicated mathematically. So you use online softwares and you give the reference of that software which has been used to calculate the sample size. You may be using ANOVA, you may be using a non-parametric test, you may be using a t-test, you may be using a non-parametric version of t-test for the sample size calculation in those respective online softwares. The basic difficulty in calculation of sample size is that the result will depend on the attribute that is to be measured or compared. Then samples of different studies are needed to compare the difference between the two groups, and it is seldom that a study is conducted to investigate only a single characteristic. But ultimately, the question still remains, how many subjects do I need? So, for that, you have to go through the review articles thoroughly, find out good studies which are actually measuring reality in a significant way. The sample size are good. Once the difference is there, once you have a good statistically significant difference, then the sample size requirement by you may not may require lesser number of individuals to be taken in the study. Coming on to the second part, the inclusion and exclusion criteria of the studies. Inclusion criteria, looking at the target population, it is usually decided by the principal investigator or the co-investigator that according to the methodology, what are the eligibility criteria, whom you want to include in the study, what type of area you want to cover, what type of specific disease you want to cover. So according to the design of the study, the inclusion and exclusion criteria will change. It is not that inclusion criteria are those who give the consent and exclusion is those who do not give the consent. Consent is altogether a different thing. Basically, consent is to be given by all the participants, even if they are included or they drop down during the study. So, inclusion criteria is the parameters which need to be fulfilled for an individual to be a part of the study, and exclusion criteria are the parameters which are fulfilled by the subject which make him unfit for the study. So exclusion criteria, that is, you apply to the subjects who may be having a high probability of being lost to the follow-up, or the treatment which you are testing is contraindicated in these subjects, or there may be some other disease or cofactor present in them which may interfere with the study results. For example, most commonly we usually do not include pregnant subjects for the many of the drug trials, or the subjects who are not able to understand the study tool, or who have some morbidity which debilitates them to respond to the verbal responses. Thank you.